Let's talk about the unseen guardian of your home. You know, the thing that's probably tucked away in a closet or a basement or out in the garage, the electrical panel. It works 24/7, but most of us, we probably never give it a second thought. Well, today, we're going to pull back that little metal cover and really understand how it all works, from the old school fuses to the smart panels that are coming out now. So, let me just start with a question for you. Think about it. Just like everything else in your house, their roof, the water heater, your electrical system has a lifespan. And an outdated panel, well, it isn't just an inconvenience. It can actually be one of the biggest hidden dangers in your entire home. So, how do you even know if your system is, showing its age? Well, your house gives you clues. These right here are the classic red flags. Lights that flicker when the air conditioner kicks on, breakers that seem to trip all the time, or maybe that faint, kind of weird burning smell near an outlet. All of those are signals that your electrical system is under some serious strain. And yeah, it probably needs a closer look. All right, let's dive in. And to do that, we have to go back to the beginning. Before we had those familiar rows of black switches, homes were protected by something way, way simpler: the fuse. A fuse is actually a brilliantly simple idea. It's basically just a little piece of wire inside a glass or ceramic tube, and it's designed to be the weakest link in the chain. So, if way too much electricity tries to flow through it, that little wire just melts, it breaks the circuit, and boom, danger stopped. It's kind of like a bodyguard that jumps in front of a threat, sacrificing itself to protect the whole system. But that whole sacrificing itself thing, that's also its biggest problem. It's super inconvenient, sure, but way more important, it can be a huge safety risk. Imagine a homeowner getting frustrated that the TV keeps blowing the fuse. They might just grab a bigger 30-amp fuse and screw it in where a 15-amp one should be. That's called overfusing, and it is so dangerous because now you're letting way too much current flow through wires that can't handle it, letting them get red hot and maybe even start a fire. So clearly, because of that inconvenience and, frankly, the danger it fuses, we needed a better way. And that led to the next big step in home safety: the circuit breaker. A circuit breaker does the exact same job as a fuse, but here's the game changer. It's a switch, not a wire that destroys itself. So when it detects an overload, it just automatically flips to the off position. Then, once you fix the problem, like, unplugging the space heater and the vacuum from the same outlet, you just walk over and flip it back on. No replacements, no guesswork, it's that simple. And when you actually put them side by side like this, the difference is just night and day. It's not just about convenience. Breakers are just fundamentally safer. You can't just jam in the wrong size, and they open the door for all kinds of other advanced protection that just wasn't possible with a simple fuse. What's really fascinating is seeing just how long this all took. I mean, we go from Edison's first simple fuses way back in the 1880s, and then it takes almost 70 years before circuit breakers really become the standard in new homes. And the innovation hasn't stopped. We've had major safety upgrades just in the last couple of decades. But just stopping those simple overloads, that was really just the beginning of the story. It turns out there are other, more sneaky electrical dangers that a standard old-school breaker just can't see. Okay, this next part is maybe the most important thing to understand. A standard breaker, or a fuse, is designed to do one job: protect the wiring inside your walls from overheating and starting a fire. It is not designed to protect you from getting an electric shock. A fatal shock can happen with a teeny tiny amount of electricity, way, way too little to ever trip a standard breaker. And that's where this little lifesaver comes in, the GFCI. This is the device that's all about protecting people. It's constantly watching the electricity going out and coming back on a circuit. If it senses even a tiny imbalance, we're talking as little as 4 milliamps, it knows that electricity is leaking somewhere it shouldn't be, like through a person, and it shuts off the power in a fraction of a second. It's your number one defense against shock, period. And then you've got its partner, the AFCI. Think of this one as a fire prevention specialist. It's like a smoke detector, but for your wiring. It's literally listening for the unique electrical sound of a dangerous arc fault. That's the spark caused by a frayed cord or a loose wire. And it shuts down the circuit before that little spark can turn into a big fire. So this table really puts it all together, right? You need a whole team of protectors for a truly safe system. You need one for the wiring itself, you need one to protect people from shock, and you need one that's specifically looking for the sparks that can cause fires. Now, just to throw a little curveball in here, some people still argue that fuses have one big advantage: their simplicity. As this Reddit user points out, a fuse is binary. It works or it's burnt out. A breaker, since it's a mechanical switch, could technically fail in a hung or partially tripped state, which could be its own kind of hazard. It's just a good reminder that, no system is absolutely perfect. So, all of this brings us right back to the original question. With everything we know now, how can you figure out the health of the system in your own home? Get ready for this number because it is wild. For about an 8-year stretch, from 65 to 73, a lot of homes were built using aluminum wiring instead of copper. We learned later that those homes are 55 times more likely to have a connection, like at an outlet or a switch, reach a fire hazard condition. It's just a really stark reminder of how much the age and the materials in your walls really matter. And it's not just about the wiring. Even those modern circuit breakers, they wear out. They have a life expectancy of about 30 to 40 years. Now, what does that mean? It means a panel that was installed in the 1980s is now past its prime and might not trip when you need it to most. So what can you actually do with all this information? Well, it really just boils down to these 5 simple things. First, know what you've got, fuses or breakers. Second, keep an eye out for those warning signs we talked about. Third, test your GFCI outlets every month. Just push the little button. Fourth, try not to overload circuits. And finally, and this is the big one, if your system is over 30 years old, just get it checked out by a pro. Look, at the end of the day, that electrical panel is the silent, tireless guardian of your home and your family. It's one of the most critical safety systems you own. So when you think about everything it's protecting, isn't it worth making sure it's actually up to the job?